Here I have a nice geometry problem for the channel. We're asked to find the area of the circle centered at D, where that circle is tangent to a much larger circle at this point T, but it's also tangent to radii of that circle. We'll call that length AB. It's also length 8. And AC is also a radius of this bigger circle. And I should point out that angle CAB is a right angle, so we're only talking about the top right quadrant of this larger circle of radius 8. And like I said, our goal is to find the area of this smaller circle that's centered at D. So let's jump into the solution. First, what we want to do is draw line segments from this point N, where the smaller circle is tangent to the radius of the larger circle, and same for points D and M. So little small segments like that. But now, because N and M are tangent points of this smaller circle within the longer line segments, we know that all of these angles are right angles. We know this angle here is a right angle because both of these angles are right angles due to the tangency of these line segments of the circle. And like I said, we know that this angle is a right angle because that's given to us in the problem, which means we're working with a rectangle here. Because both lengths ND and DM are radii of the circle, that means we're also working with a square here. This length AM is also the length of the radius of this smaller circle, and same with length AN. But now, because we're working with a square, we can find the distance from this point to the middle of the circle that I'll color in red here, using the Pythagorean theorem, because we have two sides of the triangle here that are both length r, and we just have to find the distance of the hypotenuse. So we'll call this red length h. So h squared is equal to r squared plus r squared. In other words, h squared is equal to 2r squared, or h is equal to the square root of 2 times r. Okay, but now we have another little interesting fact, and that is that D connects to T in length R as well, because that's another radius of the smaller circle. But because both of these line segments form a right angle here, we know that this red line segment that we've called H is connected to this line segment DT, and that there's continuity there. That is one continuous line segment from A to T. So we know that the distance from A to T is equal to h plus r. So that's the square root of 2r plus r. But we also know that this line segment AT is of length 8 because it's a radius of the larger circle. So in other words, we know that 1 plus the square root of 2 times r is equal to 8, or r is equal to 8 over 1 plus the square root of 2. Okay, so now we're ready to find the area of this smaller circle. So now we have r, all we have to do is plug that into the area formula of pi r squared for circles. So our area here is pi times our radius squared. But that's going to be 64 over 1 plus the square root of 2 squared, but that's 3 plus 2 times the square root of 2. And that's enough for now.